This video is on systems of linear inequalities. We're going to be doing some examples of graphing the inequalities and shading. So our first example says that y is greater than x minus 2. This is already in slope-intercept form, so we can easily graph this. We need to go ahead and put our x and our y on our axes, x and y axis, and we also need to put our count by. These are pretty small numbers, so we can just count by ones. I'm going to put a CB1 so we can count by ones. You need to know if this is going to be a dotted or solid line and which way we're going to be shading. So because this is a greater than and not equal to, there's no solid part on the inequality. This is going to be a dotted line. And it says y is greater than. So that means that we are going to be shading above the line. So greater than in our calculator symbol will be the triangle that's pointing to the top right. So I'm going to do this by hand, and then I'm going to do this in the calculator as well. I'm going to zoom in so I can graph this line, because it is still a line, but it's going to be dotted. So I'm going to focus on the coordinates first and just put the points, and then when I connect my points, I'm going to make sure it stays dotted. So my y-intercept is at 0, negative 2, so I'm going to go down to 0, negative 2 and put a point. My slope is 1, so I'm going to go up 1 and right 1. I'm going to do this as much as possible so I can make this graph as accurate as possible. So up 1, right 1, up 1, right 1. I can also go down 1 and left 1 because that goes in the same direction. It's just backwards, basically, because a negative divided by negative is a positive. Now, in order for me to make this dotted, I could keep it as it is, but I want to make sure that I can see that this is the line. I will actually connect every other dot. So I'm going to connect these two. I'll connect these two, these two. So it's almost like a dashed line instead of dotted. Kind of means the same thing. But that way I can easily see the line itself. So I have the dotted or dashed line. Now I need to shade. So again, it's saying greater than. So by hand, I know that I can put my pen on the line that I just drew. Greater than means above, so going up in value. So I'm going to draw a line just up. And that tells me that this is the half of the graph I need to shade, the top half. All the way along the line and all in the region. Now if I wanted to check this on my calculator, I would go to my calculator, I would go to my y equals, and I will type in that x minus 2, but before I press graph, I'm going to come over to this left-hand side. I'm going to press enter until I get to this symbol that pointing up and to the right. So I'm going to press enter. That's not the one I want. Enter. That one is pointing up and to the right. So that's what I want. So I'm going to press graph and make sure that it looks the exact same as on my paper. It's the same shading and the same line, except that my line on here is solid because I know that it needs to be dotted. The calculator is more beneficial for the shading aspect. The second example is y is less than or equal to 1/2 x plus 1. So again, we're going to graph this line. So I'm going to put my x and y on my axes. I count by, and these are small numbers, so I'm going to count by ones. This, since it has a solid part to the inequality, this will be a solid line. And then it says less than or equal to. Less than, the calculator symbol, is that right triangle that's pointing down and to the left. So I'm going to do this by hand first. So my y-intercept is 0, 1. So I'm going to go to 0, 1. And then my slope is 1 over 2. So rise 1, run 2. So up 1, right 2. 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 So I'm going to go as much as I can. Then I'm also going to go down 1 and left 2. So down 1, left 2. Down 1, left 2. Down 1, left 2. And again, and again. Now, this is solid, so I can connect these as they are. I do not have to skip any. I can just connect them because this is just a solid line. Now, by hand, I want to shade this because it says less than. I'm going to put my pen on the line that I just drew. And it says less than, that's lower than, so I'm going to draw a line down. This tells me that the bottom part of the line is what needs to be shaded. So all the way along the line. all in the region. And then I'm going to check this on my calculator. So this is the last example. I'm going to go back to my y equals. I'm going to clear this completely out. And it clears out the shading part too. So I'm going to type in that 1/2 x plus 1. So my 1/2 is a fraction. I'm going to put it in parentheses. 1 divided by 2, close parentheses, x plus 1. Then I'm going to come all the way over to the left, to that blinking part. I'm going to press enter until I get to that symbol. Not the symbol I want. This is a greater than symbol. This is the less than symbol. So this is what I want. I'm going to press graph and see if this is the same graph as on my paper. It's the same shading, and it looks to be the same graph. Now it does look like a little elongated. This is a rectangular graph almost. It's wider than it is tall. This one is squared, so that's why it looks a little this one looks a little not as steep as this one. But that graph is correct. So on these next examples, we're actually going to be graphing a linear equality in only one variable. Okay, this is different than up here. This is in two variables. We have y and x. When you have both y and x, your line is going to be diagonal. If you have only one variable, it's either going to be going up and down, it's going to be vertical, or it's going to be horizontal. Okay, so one variable means one set of directions. Two variables means two sets of directions, so up and right. But one variable means just one set of directions, so left and right. That's the same set of directions. And then up and down is the same set of directions. So the graph of each inequality in the coordinate plane. So again, we're going to put our x's and y's and our count bys. Let's go ahead and put them on all of them. So x, y, count by 1 on each of these, because these are all small numbers. X, y, count by 1. X, y, count by 1. So what we need to determine is, since it's one variable, these are all either going to be vertical or horizontal. We need to determine if they are going to be vertical or horizontal. So if it is an x is equal, x is greater than, x is less than, if it's the x, this is the one thing that we cannot graph in our calculator, because anything in our calculator to graph has to be a y equals. The only type of line we cannot graph in our calculator is vertical. So this is a vertical line. That means that this next one is also vertical. So going up and down. For C and D, they both have a y without an x. This will be a horizontal line. Both of these will be horizontal. Then we go to see if they're going to be dotted or solid and which way they need to be shaded. The A will be a dotted line because it does not have solid part to the inequality. So this is dotted, and it says greater than. So if we were able to do this in our calculator, it would be the triangle that's pointing to the top right. But we cannot graph these in our calculator to even look at it to see if it's correct. So we have to know how to do these by hand. For B, this has a solid part to the inequality, so this will be a solid line. And again, in the calculator, this would have been the triangle that goes to the bottom left because it's less than. On C, this does not have a solid part, so this will be a dotted line. And we will be able to put this in our calculator. It says greater than, so it will be that triangle that points to the top right. And D, it has a solid part, so this will be a solid line. And it says less than, so it will be pointing to the bottom left. So let's go and graph these. So x is greater than -1. What we do is we go to the x value of -1. On the x-axis, we go to -1. And then all of these numbers, that vertical line at x equals -1. It is going to be dotted, so I'm just going to draw a dotted vertical line through that x is -1. And then we shade it. Now, with the vertical line is the only one that the inequality actually tells you which direction to point. This is actually telling you the arrow is pointing to the right-hand side because we want all of the x values that are bigger than -1. -10 is not bigger than -1, but positive 10 is. So we want to shade to this side. This is all greater than negative 1. So for B, we go to that x value of 6. So we have 1, 2, 3, 4, 5, 6. We want a solid vertical line going through that coordinate. So all of these x coordinates on these, or all of the x values on these coordinates, would be a positive 6. That's why this would be a vertical line. Now for shading, we want less than. So this is pointing towards the left because we want the numbers that are less than or equal to 6, which is why it's solid. So 0 is smaller than 6, so we want to shade towards that 0. So this is why we shade this way. And you can make it any color you want to. I can go back over this in pencil so you can easily see it. Maybe it's a little bit darker. Same thing over here. Then for C and D, these are going to be horizontal lines. We do the same process by going to that y value of negative 4. So that y value of negative 4 is on the y-axis. 1, 2, 3, 4. I'm going to put a point there. But I want all of the y values of negative 4. And this is going to be a dotted line. So I'm just going to draw a dotted or a dashed horizontal line where all of the y values are negative 4. Then it says we want greater than negative 4. All of the y values that are greater than negative 4 are above it. So all of the values above are what we're shading. So again, I can go back over this in something darker. And that's our solution. So for D, it says y is less than or equal to 2. So again, no x variable, so it's going to be horizontal or vertical. We go to that y value of 2. And we want all of the y values of 2, so all of the horizontal, and it will be a solid line. We're going to graph a solid line at y equals 2. Arrows. And then we're going to shade. We want all the numbers that are smaller than, so less than or equal to 2. So it will include that 2, but we want everything that's smaller than positive 2, which is towards the negatives. So we're going to shade everything below this horizontal line. The last thing I'm going to put on here is just a reminder of what the calculator symbols are. So calculator symbols. So a quick reference. The calculator symbols, when you want less than, you have that right triangle that's pointing down and to the left. And when you want greater than, you want that right triangle that's pointing up and to the right. Just remember that you cannot put the shading and the dotted versus solid in the calculator at the same time. You would probably just focus on the shading aspect to make sure that you have it shaded correctly. And I do want to show you on like C and D that our graph is correct because it is a y equals, so I can graph it. So if I just clear out my problem, I'm going to put in C, y is greater than negative 4. So I'm just going to type in negative 4 in the y equals, and then come over, it says greater than, so I have to press enter, not the one I want. Greater than is pointing to the top and to the right, which is the one I want, so I'm going to press graph. And this is the same graph that I just had. The only difference is that this is a solid line because I cannot put both the shading and the dotted part on there. So I would just have to know that this is a dotted line before I graph it. So the calculator part is really to help you with the shading of it if you're not sure on what it really means for less than or greater than. This is graphing systems of linear inequalities.